Today we'll see about Oracle database architecture. So this is very important topic, and once you understand this architecture, then only you can be a better DBA. So try to get as much as possible from this architecture and let me know if you have any questions. Oracle database architecture. So we need to Oracle database architecture is nothing but uh, we have to understand how the components, how each and every component of Oracle database works, and how efficiently we can make use of those components in order to improve the performance. So that is nothing but an Oracle database architecture. Understanding how each component works and what is each component and how each component coordinates with other components in the Oracle database. So first, before starting the architecture, we'll see like if you want to store information in your computer, what are the two ways? I mean like in which media you can store the information. So either you can store it on RAM, that is memory, or you can store it in disk. So these are the two ways, these are the two medias in which you can store the information. Either you can store it on the memory or you can store it on the secondary storage like disk or tape. In the same way, in Oracle database, as we already know, Oracle database is nothing but we will have a collection of related data which is of interest to an organization. So that data will be stored either in memory or in disk. But due to the advantages and disadvantages of these two storage types, coming to memory, it is expensive but it is fast. Memory is expensive but it is fast. Coming to disk, inexpensive but it is little bit slower when compared to memory. So we need to make efficient use of disk and memory in order to improve the performance. So this is inexpensive and slow. So by efficiently using the memory and disk, we can improve the performance. So even in Oracle database, we will be efficiently using this memory and the disk, and we will see how they work each other. So in Oracle database architecture also, we will have a large chunk of memory allocated for Oracle database, which is called as SGA. SGA stands for Server Global Area. Server Global Area, SGA means. Then you will have the secondary storage, which is disk, and in this disk you will have the actual data. So whatever the content which is present in the memory, it is a volatile. So once the power is shut down, we will not have the content in the memory. So indeed, finally, whatever the content which is present in the memory needs to be written back to the physical storage, which is disk. So to write the content from SGA to disk, we will use, or Oracle uses, a processes which are called as background process. So using this background process will flush the information from SGA and will return back to the data files. But how? For example, if you are performing an insert, if you are inserting a row into the table, first it will be stored in the memory. Then immediately it will not be written back to the data files, because to write the information, to write one row to the disk, it will take a lot of time because the disk is slower when compared to the memory. So writing each row will take a lot of time. So that is not an efficient use of memory and disk together. So what we have to do, this background process will not write the content from SGA to disk as soon as the information is updated by the user. What it does is it will take bulk of statements and it will do a batch processing to push the files or to push the data back to the data files. So in this way, background process will be efficient because it, I mean, like instead of flushing the each and every row from SGA to the data files, it will push everything together at once. So this will make efficient use of memory and disk. And combination of SGA and background process, combination of SGA and background process is called as an instance. SGA plus background process is called as an instance. And this will be called as a database. So basically you will have two terms in Oracle. One is SID and another is database name. One is SID and another is database name. SID is nothing but an instance name. So SID is the name given to an instance. That is, SID is the name given to an SGA plus background process. And DB name is the name given to the actual database, the physical database. So usually instance name and database name will be same. In most of the cases, instance name and database name will be same. But still we will have a lot of difference between an instance and a database. Instance is nothing but a memory plus background process, whereas database is a physical thing. Okay, SID is the instance name and DB name is the physical name given to the database. And Oracle database is nothing but instance plus physical files. So physical files I'll represent with a cylinder, and instance I'll go for memory and then background processes. So say these are background processes. There are several background processes. We will see each and every background process and what it does. And this is an instance which is this memory which is SGA, and these two together called as an instance, and this is the physical files. So instance plus physical files is nothing but database. And we will have several components inside the SGA, and we will have several types of physical files, and we will have lot of background processes. Understanding each of the component, understanding each of the internal component of the SGA, understanding each of background process, and understanding each of physical files is nothing but database architecture. First, before starting the architecture, we will see what kind of databases we can have. So a database can either be a dedicated server or a shared server. So a database physical a database can run on two modes. One is dedicated server mode, the other is shared server mode. Dedicated server, shared server. So in a two-tier architecture, you will have a client and a server, correct? So you will have a server, and you will have a client. So in a two-tier architecture, you will have a client and a server. Basically, this will be a two-tier architecture. Now, whenever a user is trying to connect to the database, there will be associated server process for each and every client process. Say for example, if you have 10 clients or 5 clients, 5 users connecting to the database which is present in this server. So database is hosted on this server and user is trying to connect to this database. As user is requesting, he will be called as a client and the database will be serving the request and it will be called as a server. Now if you have 5 clients connecting to the database, so these are, for example, these are the 5 users connecting to the database and each and every client will have an associated server process which will be running on the server side, and this server process will take the request coming from the client, and then first the thing is like immediately whenever a user is trying to connect to the database, first a server process will be allocated for that user, then a connection will be made to the database. So for example, if you take this one, it will go to the server process and then server process will take the request whatever the client is trying to request. If you are doing select star from EMP, server process will take that request, it will run the query against the database, and then the database will give the information back to the server process. After that, server process give the information back to the user. So this is a dedicated server process. That means each and every client will have a dedicated server process. In a dedicated server mode, if you have 10 clients connecting to the database, you will have 10 server process. Each server process will take the request from specific client and that server process will serve the client. But if you see here, if 10 users are connected to the database, 10 server processes are created. In a similar way, if 100 users are connected to the database, 100 server processes will be created. And each and every server process means it will run in the memory. That means it will consume some memory, some RAM. So if you have 100 users connected to the database, 100 server process will be created and that server process will use the RAM. So if you don't have sufficient RAM on your server, then this is not applicable. I mean, like this is this will decrease the performance as each and every server process will consume the memory, and that will lead to the shortage of RAM on the server. As a result, database performance will be degrading in a dedicated server mode if you don't have a sufficient memory, because each and server process will consume space or which will consume memory. Coming to the shared server, again it will be similar. Client will be there. I'll take 3 clients and now you will have the database on a server. So I'll take it as server. And whenever you're getting a database in shared server mode, a shared server process will be created. Instead of server process, we will have shared server process. And whenever the user is trying to connect to the database, he will approach the server. Instead of having three server process, we will have only one shared server process, and this shared server process will be serving all the users. So as a result, we will, like if you see here, there are no 100 server process running on this server. So it will consume less memory. So whenever you are shortage of resources, you will try to configure the database in a shared server mode, and whenever you have sufficient resources, you will try to configure the database in dedicated server mode. And not only that, if you have a dedicated server mode, the response time will be quick, because each and every client will have associated server process, and that server process will work in parallel with other server processes, and they will give the information back to the users. So the response time of the dedicated server mode will be faster when compared to the shared server. The reason is, in shared server process, if I go deeper into the shared server process, database or a server, now user will be here and he's trying to connect to the database, and this is a server where the database resides now, and there is a shared server process which is running on this server. Whenever the user is trying to connect to the database, a process called as a dispatcher process is created. For each and every client, there will be associated dispatcher process, and this is a shared server mode, and this is not a server process. Remember, this is a dispatcher process. There is a difference between a dispatcher and server process. Dispatcher is very lightweight process. That means it will consume very less amount of memory compared to the server process. So that is the reason why, even though we have dispatcher for each and every user, it will not consume lot of resources. It is a lightweight process. So if three users are connecting to the database, there will be three dispatches running on this server, and all the dispatches will take the request from the user, and it will submit to the shared server process. So whenever the dispatcher take the request from the client and submit to the shared server process, it actually goes into a queue. So for a shared server process, there will be a queue called as a request queue, and there will be another queue called as a response queue. So I'll draw the queues here. One is response queue, another is request queue. So this will be a request queue, and this will be a response queue. Now the dispatcher, whenever it is trying to place the request to shared server process, it will keep the request into the request queue. So it will be a first in first out. So whoever the user trying to request, or whoever the user trying to run the query against the database, he will be running the query against the database first. The reason is, he is the first user log into the database. So as a result, dispatcher process will place the request into the queue, and as this is the first entry in the queue, this will be taken by the server process, and it will serve the request, and it will put it into the response queue, and from the response queue, dispatcher will take the response and give it back to the user. So if you see here, it will be in the queue. The response time will decrease. If the third user comes in and he tries to request, he needs to wait until the shared server process serve the request for the user 1 and user 2. As a result, the response time will be slower in shared server process. So it's a trade-off. If you want the response time fast, you need to configure the database in a dedicated server mode. If the response time doesn't matter, then you can go for a shared server mode. And also you need to take a look at your resources. If you have sufficient memory, you can go for dedicated server mode. If you don't have a sufficient memory, and CPU also, because each and every process will take the CPU usage too. So if you have sufficient memory and CPU, then you can go for dedicated server mode. Do you have any questions between dedicated and shared server? So first we will see whenever user trying to connect to the database, what will happen. So again, this is the server. This is the database, which is a physical storage. And as I said, we will also have a large chunk of memory, which is called as an SCA. There will be a user. Whenever he is trying to connect to the database, first he will contact the server by using a host name. For example, the IP address of the server is 192.168.1.70. If you remember, I said we can connect to the database in three ways. One is we can connect to the database by within the server itself. So by logging into the Linux server, we can do SQL plus Scott/Tiger and you can connect to the database. The second way is you can have a client software, and using that client software you will connect to the database server, which is a two-tier architecture. And the third will be a three-tier architecture. First it will go to the web application, and from web application it will go to the database. So this, whatever I'm showing, will be applicable for a two-tier architecture. So client will be sitting on a Windows machine and the server is on Linux machine. Now if the user is trying to connect to the database from his Windows machine, from the client machine, the first thing what it requires is IP address. Without the IP address you cannot communicate with the server, correct? So you need an IP address in order to communicate with the server first. So this will take the connection until the server, but within the server you need to go to a database, correct? So each and every database will run on a port. Give me a second. Okay, sorry. So first, with the port number you will be connecting to the server. So using IP address we'll approach to the server, but to connect to the database, in this server you may have 2 or 3 databases running on this server. Hello, are you able to hear me? Hello.
Yeah.
Okay.
Yeah.
Yeah. So for example, there are 2 databases running on this server. As I said, database is nothing but combination of RAM and the physical files along with some background process. So let me put BP here, which are background process. Altogether this is one database, and another is there is also another database which is running on this server. Now there are 2 databases running on this server. So with this IP address you cannot go and connect to one of the database. You need to know a database name to which you are connecting to. The second thing you require is a database name. So to which database you want to connect to. So for example, you have dev and test database, then you have to specify I'm going to connect to dev database. So you have to specify the DB name. And then by specifying the DB name itself, you cannot connect to the database. Each and every, there will be a port number. On that port, a service will be running, and that service will make a connection to the database. So you need to know the port number on which the server, on which the service is running. So the third thing you require will be a port number. So by having the IP address, you can go to the physical server. But with the port number, you can connect to a specific process which is running on that server. And then after that, it will go to the database. So these are the three information, or these are the three inputs which you require in order to connect to the database from the client machine: IP address, DB name, and port number. Apart from that, once you approach the database, you need to have a username and password like Scott and Tiger. So we also need to specify the username and password. So by using this information, you will connect to the database from a client machine. So these are the pieces of information which you require in order to connect to the database. So let me show you. This is a Linux server, and this is the Linux server. Next, I will be opening a client software which is called as a SQL Developer. It's a free tool. You can download it from online. Now, you'll click on plus. Plus will create a connection. So whenever you are trying to open a SQL Developer, you need to first create a connection. So you need to click on this plus. After that, you have to specify the username and password, which will be Scott Tiger. Then you have to specify the host name. So I know the port, I know the IP address, which is 192.168.1.70, and the port number is 1521, and the database name to which I'm connecting to is dev. Then you can click on test, which will check the connectivity. If the status is success, that means you'll be able to connect to the database. Now I'll click on this connect. Okay, let me make it as dev_2 connect. So once a connection is made, on the left side, on top of this symbol, you can see an image with plugin. So that means you are connected to the database. Now you can query, or you can submit a request to the database. This will fetch the information and it will give it back to the user. So in this process, so whenever user is trying to approach or is trying to connect to the database with IP address, port number, DB name, user credentials, first it will go to the physical address of the server. After that, on a port which it specifies, actually there is a process called as listener process, LSNR, listener process. It's a listener process, shortcut will be LSNR, and this process will run on a port number. For example, this process is running on a port 1521. So this listener process will validate IP address, port number, and DB name. So it will check whether on this port 1521 the DB name dev is registered or not. Yes, if it is registered, then it will create a process called as server process in a dedicated server mode. So this is a dedicated server mode. In a dedicated server mode, once listener authenticates that service is running or the database is running on port 1521, it creates a process called as server process. And this server process will make a connection to SGA. So every time whenever user tries to insert, delete or select the information, it actually happens through memory. So all the inserts, selects, deletes, updates, alter, create, everything, first it will happen in the memory and then it will go back to the disk. As it happens in the memory, it will be faster. If it directly goes to the disk, it will be slower. So this is how efficiently Oracle database uses memory and disk. So all the user connections will approach SGA. Then once it approaches SGA and connection is made, it establishes a direct link between the user and SGA. So whenever the user is trying to connect to the database, these are the steps. First it will go to the listener and then listener process will create a server process and server process will make a connection to the SGA. Once it makes a connection, it will establish a direct link between a user and the memory. So listener is required in order to make a connection to the database. Once the user makes a connection to the database, we don't require this listener process. The reason is once a connection is established, it actually establishes a direct link between a user and the SGA. So only whenever the user is trying to make a connection, we require the listener process. Once the connection is made, we don't require this listener process. Is it clear?
One question, Mohan, like how can we know that port numbers? I mean, is there any way we can get the port numbers?
I'll show you now.
Okay, yeah, that's fine. And
So,
one more, that's will come later. I mean, I'll check with later. I mean, after this sometime.
okay.
Yeah.
So this server process will make a connection to the SGA and then the user will make a connection to the database. After that, user tries to issue, as for example, user is trying to issue a query, select star from EMB. First, the server process will check whether the requested table is present in the memory or not. If the requested table is not present in the memory, the background process, server process itself will take the information from the physical storage and it will put it into the memory. Once it places a table in the memory, then from the memory, server process will give back the requested information back to the user. So this is how whenever a user is trying to query the table, first server process will check the requested table is present in the RAM or not. If it is not present, it will get the table from physical storage and it will place that in the RAM, such that whenever second user is trying to fetch the same information from EMP table, then the second connection, whenever the second user is trying to request the same information, it will not go to the physical storage. It will give the information back to the user from memory itself. So as a result, the subsequent access to the same table will be faster. Even though initial access will be little bit slower, the subsequent access will be faster because the table is present in the memory. So that is the reason why Oracle uses RAM in order to provide faster retrieval and faster access to the database. So this is the flow in which dedicated server process works. Next, I will see you the I'll show you the flow in which shared server process works. Shared server mode. Similar SGA, database, and then user. So with all those details, he'll try to make a connection to the database, and on the server there is a process called as listener. Remember, listener process always runs on the server. So this is the listener process, and it runs on a port, as I said. Now, once listener authenticates the database is running on this port number, it will create a process called as dispatcher process. Dispatcher process. And this dispatcher process will have this dispatcher process will put the request into the shared server process, or first it will connect to the shared server process. This is a shared server process, and then this makes a connection to the database. Once a connection is established, a direct link will be established between the user and the database. After that, whenever a user is trying to select the information from the table, select star from EMP, this dispatcher process will put a request into the queue. So shared server process will typically have two queues, request and response queue, and dispatcher process will put the request into the request queue of shared server process, and this shared server process will pick the request and it will run against the database. Again, the same thing again. First it will check in the memory. If it is not present, it will fetch the table from physical storage and it will put it into the memory. After that, it will process the information and it will store it in the response queue. From the response queue, dispatcher process will take the information and give it back to the user. So this is a flow in which shared server mode works. And even if the second user is coming in and trying to make a connection, it will be the same thing, except it will connect to the dispatcher and dispatcher will in turn make a connection to the shared server process. Any doubts?
No, no, I'm good. Yeah.
So first we will see how to create the listener process, how to start the listener process, and how to register a database name into the port. There is a utility called as lsnrctl. Using this utility, we will start a listener. Using lsnrctl utility, we will start a listener. So in order to start the listener, the command will be lsnrctl start listener. So this is a command which will start the listener process. So once the listener is started, you can check the status using lsnrctl status listener. So this will show you on port 1521 the database name dev is registered. This is how you have to check on which port the database is running. So whenever a user is trying to connect to the database, he will request the information from the DBA. So you need to provide the port number and the host name. So now we cannot use this host name. You have to specify the physical IP address. So you'll give the port number, IP address, and then service name, which is registered onto the listener. So host name will be IP address, port number, and then the service name will be database name. So this is how we can check on which port the listener process is running and whether the database is registered into that listener or not. And by default, all the listeners will be running on port 1521. And in the future classes, whenever I'm teaching about the networking concepts, you will know how to change the port number and how to create a different listeners and everything, and how we create a listener and what is the listener.aura file, everything. So for now, just to do practice from your side, you have to issue the command lsnrctl start space listener. So that will start a listener on a port 1521. After that, automatically the database name will be registered onto the listener. You don't need to do anything. You just need to start the listener. So once you start the listener, the database name will be registered into the listener, and that service will be running on port 1521 for now. Okay. Now, if you want to check whether what is the server process on the Linux, as I said, this will be the client process. SQL Developer is a client process, and this will make a connection to the database. Once a connection is made, a server process will be created. So if you want to check the server process, the command will be ps-ef grep local grep no. Actually, if you see, this connection is coming from a remote machine, so that will be local equal to no. If local equal to yes means the connection to the database was made from the local server itself. But I want to go for a remote connection, the connection which was made from a remote machine. So that is the reason why I'm grepping it with local and then grep with no. If I grep with yes, I will get the local connections. If I grep with no, I will get the remote connections. So if you see here, I have two connections, and this was the connection which I made just now at 10:44 p.m. So it will show you the time at which this server process was invoked. So as two users are connected to this database, there are two server processes running on this server. In a similar way, if 100 users are connected to the database, you will see 100 server processes running on this server. This is how you will check the server process. ps-ef grep local grep no. Okay. Now, if you want to see the memory consumed by this server process, ps space v space process id. This is the command which will show you how much memory the process is using. 27768. So you have to look at RSS column, and if you look at that one, it is actually the output will be in kilobytes. So if you see here, this process is actually consuming 49 MB. If you take off last 3 digits, it will be in megabytes, because 1024 kilobytes is nothing but megabytes. So that is the reason why I'm taking off last 3 digits. So approximately it will be 49 MB. So this server process alone is taking 49 MB of memory. So likewise, if I have 20 server process, it will consume 40 into 20, 180 MB of RAM. Sorry, 40 into 20. It will consume 800 MB of RAM. Okay. So if you don't have sufficient memory, you will configure a shared server process, because usually to the database there will be 100 or 1000 users connecting to the database. Okay, this is how you can check how much memory the process is being used. Clear? How to check the server process and how to check the memory usage and how to start a listener and how to check the status of the listener. And if you want to stop the listener, the command will be lsnrctl stop listener. This will be the command to stop the listener. And to use these utilities, you need to make sure you run this script, because without running setdb lsnrctl, if you just issue the command lsnrctl start listener, it will say lsnrctl command not found, because it will be lsnrctl is a utility which comes with rdbms software, and as a result lsnrctl utility will be present in oracle home / bin folder. Okay, Girish, you there? Girish,
Hello?
yeah,
Yes,
Girish,
yes, I'm here.
are you sleeping? ఆశీష్ నీకేమైనా డౌట్స్ ఉన్నాయి ఇప్పటిదాకా? ఆశీష్,
మోహన్ అర్థమవుతుంది మోహన్.
నువ్వు అసలు నువ్వు యాక్చువల్గా వీడియో ఇప్పుడు క్లాస్ చూస్తున్నావా లేకపోతే జస్ట్ ఫోన్లో వింటున్నావా?
లేదు క్లాస్ చూస్తున్నా, క్లాస్ ఉందా అన్న.
ఓకే,
అదే మైక్రోఫోన్ పనిచేస్తలేదు, అందుకే నేను ఫోన్లో వాడతా.
యా అదైతే ఓకే. కాదు ఇప్పటివరకు ఏమైనా డౌట్స్ ఉన్నాయా?
ఇప్పుడే అర్థమే మోహన్. యా
షూరా?
ఆ,
ఓకే.
ఓకే.
Once actually I try to understand about the this concept new one. That's why I'm in a mood.
ఓకే ఓకే, యా
Okay.
I'm having some network issues, so I relog in now just now.
యా దట్స్ ఓకే.
Yeah.
So this is how you can check the server process which is running on the server. ps-cf grep local now, and then to check the memory usage we will use this command ps space v 27768, and RSS is the physical memory. RSS column is a column which will show you how much physical memory this process is being used. And using lsnrctl we will manage the listener. We can start, stop or check the status of the listener. And lsnrctl utility comes with rdbms binaries, so you need to make sure you set the db, you set the database environment first before using these commands. Next we will see how can we connect. I already configured the database in shared server mode too. So in the future classes you will know how to configure database to a dedicated mode or to a shared server mode. But just I want to give you a contrast, and I want to show you what is the difference between a server process and a dispatcher process. What is the difference in the resource usage? So if you see here the memory usage is around 49 MB. So the same thing if you connect to the database using a shared server configuration. So I will show you that. Okay. Now let me make a connection to the database using a shared server configuration. Okay. So this is using a shared server configuration. I'll show you in the future classes how to configure this one. For now. Okay. Now I made a connection to the database and I can fetch the information from EMP table. Okay. I'm able to fetch the information. I'll go back to the Linux machine. In order to check the dispatcher process, the command will be ps-ef grep ora underscore d. This will show you the dispatcher process which is invoked. So only one user connected to the database using a shared server mode. As a result, there will be one dispatcher process. And remember, for each and every user, you will have a dispatcher process. And this dispatcher process will be a lightweight process. So let us go ahead and check the memory usage of this dispatcher process. ps space v space process ID. So this will be the process ID. If you remember, in the process command, the second column will show you the process ID. The first column will show you the process, will show you the user who invoked the process. So the second column is 5426. So if you see here, the process usage of this one is 15 MB. So it is very less when compared to server process. So that is the reason why a dispatcher process is called as a lightweight process, and it will consume very less memory compared to the server process. And you cannot check the command ps-ef grep local grep ps or grep no. This will not show you, this command will not show you the server process. I mean, like, if you see here, it is still showing only two server process. Even before invoking a connection, it showed two server process, and after making a connection also it showed two server process. The reason is, whenever you are connecting to the database using a shared server configuration, server process will not be created. Only a dispatcher process will be created. And for all the dispatcher process, there will be one shared server process. If you want to check whether the shared server process is running or not, the command will be ps-ef grep ora underscore s. So this is the server underscore s 000. This is a shared server process. So if you want to check whether the shared server mode is enabled on your database or not, you need to issue this command ps-ef grep ora underscore s. If shared server process is running, that is S000 process is running, then that means your database is also configured for shared server mode. And if you want to check the dispatcher process, this will be the command ps-ef grep ora underscore d. Next, as I said, SGA, are you able to hear me?
Yes, no.
Yeah.
Okay. So next we will see instance, background process, and database. So all these components together called as a database. That's what I said. Instance, background process, and physical files all together called as a database. Now, how many databases we can have on the server? We can have as many databases as we can, provided if we have the resources. That means if we have memory, if we have CPU, then and also the storage. Then you can have as many databases as you want. So on a server you can have 10 databases or you can have 20 databases.
Okay.
Next, an instance and the background process will be associated to a database. So one instance, and this, like as I told you, SGA plus background process together called as an instance. This is SGA and this is background process together called as an instance. And this instance will act for this database. That means you can have instance to database, will be one-to-one mapping. One instance will coordinate with one database, or you can have two servers. One is server A, another is server B, and on this server you will have the SGA and you will have the background process. In a similar way, you will also have SGA and background process on server B. And this is instance 1, this is instance 2. And both these instances which are running on server A and server B can coordinate with a database which is stored in shared location. So this is nothing but the physical files. So you can have disks connected over the network such that these disks can be shared across server A and server B. So this kind of configuration will be called as a shared server. Like shared disk or shared storage. So this is a shared storage, and on this shared storage you will have the physical files corresponding to the database, and then you will have instance 1, instance 2, and both the instances will coordinate with single database. So you can also have two instances coordinating with one database. So whenever you have an instance to database in one-to-one mapping, this will be called as a standalone database. And whenever you have two instances coordinating with one database, it is called as a cluster. The full name, it is called as a RAC actually, and the full form of RAC will be Real Application Cluster. Real Applications or Real Application Cluster. So first thing is you can have the database running in shared server mode or dedicated server mode. The second thing is you can have the database as a standalone database or real application cluster database. And first we will cover the standalone part, which is one-to-one mapping of instance to database. Once we complete this standalone, we will go for RAC. The standalone itself will take 30 days, I guess, to complete the standalone. And after that, whatever the techniques we will use for standalone will be applicable for RAC also. So only the difference will be how to install the software and how to create the database. So that part I'll show you. After that, everything will be similar to the standalone in the RAC. And the third one option can be, can two databases associate with one instance? Can we have one-to-many mapping between an instance and a database? This is not possible. The only mappings which we can have will be many to one or one to one. We cannot have one to many mapping. So this configuration is not possible. These are the only two configurations which are possible. Either we can have standalone or a rack. Any questions?
Yeah, Mohan, one question. I mean, I think maybe it's not related to this one.
Mhm.
Actually, how can we connect to different database on the same server through PuTTY? I mean, like,
No, putty is nothing like the only difference. Like I'll show you.
no, yeah. Suppose here we are connecting to test server, right? Like,
Yeah.
what we are.
So within the server, if we have two databases, how to connect to the second
Yes,
database? That's your question, right?
yes, yeah.
So whenever you are trying to connect to the database, the first script which will run will be setDB, correct?
Yes, maybe
In,
in that
in
we can
setDB, we have an option called as oracleSID. This is an environmental
Yeah.
variable which will specify in order to connect to the database. So if you want to connect to the second database, which is test, export oracle underscore SID to test, and you can connect to the database.
Yeah, got it. Yeah, thanks.
Yeah. Okay, I'll wind up the class here and I'll continue tomorrow.
Okay.
I don't want to tell all the concept at once because you'll get confused.
Yeah, definitely.
Yeah. So theory part, if there is a theory part, I'll take 1 hour class. If it's a practical part, I can take 2 hours of class.
Okay. Thank you, Mohan.
Yeah, okay then. Bye.
Yeah. Yeah.
And tomorrow class will be at 10 a.m.
Yeah, sure. Yeah.
Okay. Yeah.
Thanks.
Okay, ma'am.
Bye. Hello? 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 Shravani? Hello? 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 అయిపోయింది అయిపోయిందిరా చలో నడుపా హలో హలో యా చెప్పు చెప్పు ఓకే ఓకే అది కాదు, అది రెండు విత్ జావా ఫైల్ విత్ నో జావా ఫైల్ ఆర్కిల్ నుంచి డౌన్లోడ్ చేసి నువ్వు డౌన్లోడ్ చేయాల్సింది విత్ జావా. నీకు ఒకసారి చూపిస్తాను. అవసరం లేదు, నేను చెప్తాను చూసి ఎగ్జాక్ట్గా. పదా భయ్యా పదా వెళ్దాం పదా. ఓకే, ఇక్కడ సీక్రెట్ డెవలపర్కి వెళ్ళిన తర్వాత విండోస్ 32-bit ఫైల్ ఇంక్లూడ్స్ JDK అన్నారు. ఆర్కిల్ సైట్ అది డౌన్లోడ్ చేసి డైరెక్ట్ ఓపెన్ విత్ JDK ఫైల్ నోట్ చేసి ఏమవుతుందో నువ్వు JDK చేయాలనుకుంటా. నువ్వు లేదు విత్ ఇంక్లూడింగ్